Welcome to the second Unit 6 lesson. It's on Chapter 7.2 and 7.3. Let's recall what we've learned from the previous lesson. So supplementary angles are two or more angles that when you add them up together, they equal to 180 degrees. And transversal line is the line intersecting two or more parallel lines. On our D2L classroom, I have posted two links under today's lesson for you to practice and refresh your memory on supplementary angles and the transversal line. Let's move on to today's lesson. The sum of interior angles of a quadrilateral is 360 degrees. So remember, a quadrilateral is a four-sided shape. Okay, so the interior angles, so 1, 2, 3, 4, have to add up to 360 degrees. The sum of the exterior angles is 360 degrees. Okay, so there is an example here. So the interior angles A, B, C, D add up to 360. The exterior angles W, X, Y, and Z also add up to 360 degrees. Okay, so let's find the measure of the unknown angle in each quadrilateral. Okay, so here we're finding an interior angle. So remember that the sum of interior angles of a quadrilateral is equal to 360 degrees. So that means that 56 plus 95 plus 98 plus X is equal to 360. So X plus 56 plus 95 plus 98 is equal to 360. Okay, so now let's collect our like terms, simplify, and then isolate our unknown variable. And then don't forget your units, degrees. Okay, and B, so we're trying to find Y. So that's an exterior angle. Now remember, exterior angles also add up to 360 degrees. Okay, so 50 plus 88 plus Y plus 105 is equal to 360. Okay, simplifying my like terms and then isolating for my unknown. Okay, moving on. Use this diagram to determine two of the angle properties of a parallelogram. So here's a parallelogram. So we're just going to determine two properties. Okay. Well, these double arrows indicate that those sides are equal. And these single arrows indicate that those two sides are equal. Okay, but it's asking us about angle properties. So those are sides. So let's look at the angles now. So this angle is 103 degrees and its opposite angle is also 103 degrees. So opposite angles are diagonal to each other. And then it's also true for these two opposite angles. Okay, so that's an angle property of a parallelogram. So one property, opposite, which means diagonal, angles are equal. Okay, and another property of parallelograms, I'm just going to erase all this, is that it actually follows the C pattern or the co-interior angles pattern. So these two interior angles add up to 180 degrees. And the same over here. Here's my flipped C, but it's still following the C pattern. These two angles add up to 180 degrees. Okay, so they're supplementary, which means they add up to 180 degrees. And that we learned or reviewed yesterday. That's called co-interior angles, or the C pattern. Okay, so that's all we're going to learn about 7.2. So we're going to move on to 7.3. Let's review two terms that we've learned already. So a polygon is a close figure formed by 3 or more line segments. And a regular polygon is a polygon with all sides equal and all angles equal. Okay, here are some examples of regular polygons. The first one is a square. So I'm indicating by these ticks that all the sides are equal and all the interior angles are 90 degrees. Next, we have an equilateral triangle. So again, all sides are equal, all angles equal. Pentagon, a 5-sided shape. All sides are equal, and all angles are equal. And then a hexagon, 6 sides equal, 6 angles equal. Okay, and notice that there are always the same number of angles as sides. Okay, that's just for you to note for, I think, the next page. Although triangles and quadrilaterals are the most common shapes in construction, you will find many other types of polygons in both natural and manufactured objects. There's 2 types of polygons, a convex polygon and a concave polygon. So the convex polygon is here. It's outlined here in blue. So here's my polygon. So a convex polygon tells me that if I drew a line segment, so remember a line segment is a straight line. So if I drew one line segment outside of this polygon, I would not be able to connect from one vertex to the other. Okay, so here's a vertex. If I drew one line segment, okay, I wouldn't be able to connect to any other of these other vertexes. Okay, obviously besides the side, the actual line segment. So I'm saying an additional line segment. Can you draw an additional line segment, just one, to connect one vertex to the other? And you cannot in a convex polygon. Then we have a concave polygon here outlined in blue. And in this type of polygon, you can create one line segment that would connect 2 vertices together on the exterior of the polygon. Okay, another way of thinking about it is the word is concave, and concave means that it caves into its own polygon. All right, so we're going to complete this chart with just some facts about each of these different types of polygons. So the first is a triangle, and number of sides we know is 3. 1, 2, 3. The number of diagonals from one vertex to the other is 0. So diagonal, going back to here, we said diagonals is opposite angles. So are you able to create a diagonal from one vertex to the other? So let's say we start here. Well, to get to one of these other vertexes, we'd actually just have to follow the line segment that's already there. So we can't create another line. So there are no diagonals from one vertex to the other. The number of triangles in the polygon. Well, there's one. Here it is. And the sum of the interior angles is 180. Sum of exterior angles is 360. Next, a quadrilateral. Number of sides, 4. Number of diagonals from one vertex to the other. Well, that would only be 1. I'm going to use a ruler just to keep everything neat. Okay, so one vertex to the other, I'm able to draw one diagonal, which then would create 2 triangles. Here's one triangle and here's a separate triangle. Pentagon, 5 sides. And the number of diagonals from one vertex to the other. So we're only choosing one vertex. You know, you can pick this one or this one, whatever you want. Let's say I'm going to pick this one. Okay, so from that one vertex, how many diagonals can we create? 2. Okay, and that therefore it creates 3 separate triangles within the polygon. Okay, next we have a hexagon. Okay, so hexagon means that there's 6 sides. Okay, and again, I'm going to pick one vertex. Let's pick this one. And how many diagonals can I draw from that one vertex to all the other possible vertices? I'm able to draw 3 diagonals, which then would create 4 triangles within the polygon. Okay, so here in this row, we actually have to fill out the sum of interior angles and sum of exterior angles. So there is a pattern that's occurring here. So the number of triangles that you can create in a polygon, if you multiply it by 180 degrees, you will actually end up with the sum of interior angles. So 1 times 180 is equal to 180. Let's try for this one. So the quadrilateral, if I multiply 2 times 180, you'll get the sum of its interior angles. Okay, next, 3 times 180 is equal to 540. So let's do this over here. So 4 times 180 is 720. And I'm just going to let you know now that all polygons have a sum of exterior angles that are 360 degrees. Okay, so this column we can actually just fill in. Okay, all polygons have a sum of exterior angles equal to 360. All right, a heptagon, that's 7 sides. So again, I'm going to pick one vertex and create as many diagonals as possible. Okay, so I was able to draw 4 diagonals, which created 5 triangles. So now I'm going to multiply 5 by 180 to get the sum of my interior angles, which is 900. And finally, an octagon means that it has 8 sides. I'm going to pick a vertex, 5 diagonals, which creates 6 triangles. So I'm going to multiply my number of triangles in my polygon by 180, and that is equal to the sum of my interior angles. You do not have to memorize the number of triangles in a polygon in order to then multiply by 180 to get the sum of the interior angles. What we've done is we've created a formula for you. So for polygon with n number of sides, the sum of the interior angles in degrees is, so the sum is equal to 180 times n subtract 2. So depending on how many sides there are in that polygon, you just insert a number of sides in for n, and you subtract it by 2 and then multiply by 180, and that'll get you the sum of interior angles. Okay, so remember I said the number of sides is also the same number of angles. So that's why here you're going to plug in number of sides, but then you're going to get the sum of the interior angles. It works because the sides and angles are always the same number. So let's practice using that formula in a bunch of examples. Example 1, calculate the sum of the interior angles of a decagon. So decagon, deca, means 10 sides. Okay, so we're trying to calculate the sum. Okay, so that means that our n is equal to 10. So I'm going to start off by writing my formula. And then wherever I see n, I'm going to substitute 10. Simplify my brackets, and then multiply by 180. Therefore, the sum of the interior angles of a decagon is 1,440 degrees. Example 2. Find the measures of each interior angle of a regular polygon. So remember, a regular polygon, that means that all angles are equal. Okay, so I'm going to read the question again. So find the measures of each interior angle of a regular octagon. So octagon, that's an 8-sided shape. So n is equal to 8. So sum is equal to 180 n minus 2. I'm going to plug in 8 for n, simplify my brackets, and then multiply by 180 degrees. Okay, but the question is asking us to find the measure of each interior angle. So this 1,080 is the sum of all of the angles inside the octagon added up together, right? So we need to find what each interior angle is equal to. But remember, this is a regular octagon, which means all the angles are equal to each other. So what we can do is we can take our sum and divide it by how many number of sides we have, which is 8. And our sum is 1,080. So that's 135. So that means that each interior angle of a regular octagon is 135 degrees. How many sides does a polygon have if the sum of the interior angles is 1,800? So how many sides? We're trying to find n. Okay, so now we're given the sum. Okay, so instead of substituting in my formula for n, this time we're going to substitute our value that we are given in the question in for sum. We have to find n. So let's start isolating for n. I'm going to divide both sides by 180 in order to get rid of this 180. So now I'm just left with n minus 2 on my right side. Okay, and now I'm just going to bring my negative 2 to the left, and it becomes positive 2. Okay, so that means that with a polygon with interior angles added to 1,800 has 12 sides. Find the sum of the interior angles of a polygon with 12 sides. Okay, so my n is equal to 12. Start off with my formula. Okay, and then I'm going to plug in my n value and simplify. Okay, so the sum of my interior angles is 2,160. And then substitute my n value and then simplify. And please don't forget your units, which are degrees. Find the measure of each interior angle of a regular polygon with 14 sides. Okay, so my n is going to be equal to 14. It's asking us to find each interior angle of a regular polygon. So that means that all angles are equal. Okay, so let's first start off by finding the sum of the interior angles. Oops. Okay, so in total, all of the angles, the interior angles will add up to 2,160 degrees. So now I want to find what each interior angle is equal to. So interior angle is equal to the sum divided by how many sides there are. Okay, so you can only do this when it's a regular polygon because all the angles are equal. Okay, and I get a decimal and I'm going to leave it in decimal form. Example 6. How many sides does a polygon have if the sum of its interior angles is 3,240 degrees? So this is my sum. How many sides? I'm trying to find n. So this time I'm plugging in my value for sum. I'm trying to find n. So I'm going to divide both sides by 180 to eliminate that 180 on the right side. Okay, so therefore this polygon has 20 sides. Okay, so the last two questions are just a little bit of a higher level thinking questions. So let's get to it. How many sides does a polygon have if each of its interior angles measures to 144 degrees? How many sides? So we're trying to find n. Okay, and it says that each of the angles, interior angles, is equal to 144 degrees. So that means all angles are equal, right? And all angles are 144 degrees. Okay, so I'm going to let n represent how many sides and or angles there are. Okay, because the question asks for how many sides, but we're given angle information. And because there's always the same number of sides and angles in a polygon, I'm just going to write side/angles depending on the information that I'm either inputting or gathering. So since each interior angle is equal to 144 degrees, therefore my sum would equal to 144 times number of sides. Okay, so the sum is all of the interior angles added up together. Okay, and it tells me that all the interior angles are equal to each other. One interior angle is equal to 144. So we're going to multiply that by however many sides there are, which we're trying to figure out. Okay, I'm going to start off with my formula. And now for sum, I'm going to plug in my variable. Okay, and I'm trying to find n. Okay, so I can't divide both sides by 180 because there's this n here. So I can't divide 144n by 180 because they're not like terms. So instead, what I'm going to do is I'm going to distribute my 180 into the binomial. And then 180 times -2 is -360. Okay, so now I'm going to collect like terms. I'm going to bring both n terms to the left side. Okay, and then simplify my left side. Okay, and now I want to isolate for n, so I'm going to divide both sides by -36. So therefore, a regular polygon with interior angles of 144 degrees has 10 sides. And last example, Billy is making a picture frame that is in the shape of a regular heptagon. So a heptagon means 7 sides. At what angle should adjacent sides of the frame meet? So adjacent means sides that are beside each other. Okay, so these two are beside each other and they meet at a vertex. So this is just another way of saying an interior angle. So saying what angle should the adjacent sides meet is that really just asking what should the interior angle be? Okay, and this is a regular heptagon, so equal angles. I'm going to start off with my formula. And then I'm going to plug in my n value and simplify. Okay, so the sum of the interior angles is 900. Now remember, this is a regular polygon, so we can use that other formula. Interior angles is equal to sum divided by number of sides. So 900 divided by how many sides? So each interior angle is about 128.6 degrees. And in my therefore statement, I'm going to use the same wording that was presented to me in the question. Okay, and there are some questions here from 7.3 that you can try in the textbook, and then of course today's quiz. If you have any questions about today's lesson, please reach out to me and ask.